Go.
Hey, Miss Dunbar's class. My name is Stassya, and I'm here to tell you guys more about the ocean and the inner workings of it. Let me just throw some ocean facts at you real quick. The ocean, if you can believe it, covers 71% of the Earth's surface. So the ground we're on right now is the other part, the other approximately 30% of the Earth's surface. The rest is entirely ocean, and it also makes up 97% of the Earth's water. So only 3% is fresh water, which is the kind that we can drink. Now, right now in the background, maybe you can see a little bit, you can kind of hear the waves crashing against the beach and making a lot of noise. Now, waves and currents are an important part of the ocean and how it works, but they're a little bit different. Currents can refer to water, it can also refer to air, and it refers to a horizontal movement in one particular direction. Now, the Earth, you may not be able to feel it, is actually spinning. It's always spinning. And because the Earth is spinning, that means that all water in the northern hemisphere, north of the equator, which is where we are right now, always goes to the right. But water in the southern hemisphere always goes to the left. This is called the Coriolis effect. And now, because of the Coriolis effect, there's something called gyres, which are currents, so currents meaning water moving in one particular direction that move around in circles because of the rotation of the Earth and dictate what the rest of the currents throughout the entire ocean on the whole of the planet are. So that means where the water's moving and how it's moving and what direction. It's not just random. But the waves. So let's get back to the waves because they're beautiful and it's super fun when we're at the beach. Waves are also caused by movement of the wind. So when the wind is moving sort of slow or not very hard against the top of the ocean, it moves the top of the water. But when it's moving consistently and strongly in one direction, it starts to move farther down in the water. The water feet below the surface of the ocean also is moving. So that means when you have wind moving in one direction long enough, you have water being pushed on the top and water on the bottom moving also, and the water on the bottom is always going to hit the beach first before the rest of it hits, and that's how waves start to top off and break as they come onto the beach and they run into land and they run into the land under the water that we can't even see. But we're kind of high up right now. Let's go get a closer look and we'll talk a little bit more about what's happening under the water. Let's go over here. Now that we're a little closer, we can see the ocean itself a little better and also the beach. We're on the wharf right now at the Capitola Beach in Capitola on the Monterey Bay. So we've already talked about how the centrifugal forces, or the motion of the Earth as it rotates, creates currents and creates the Coriolis effect, and how waves are created by the speed, duration, and direction of winds across the water. But another important part of the movement of the ocean are the tides, and the tides are created by something entirely different. The tides are actually created by the gravitational pull of the stuff that we see in the sky every single day, the moon and the sun. Now the sun is a whole lot bigger than the moon, but the moon is actually 400 times closer to us here on Earth than the sun is. So the way the moon moves actually has a greater effect on the way the ocean moves and the tides than the sun does. So the tides themselves are the periodic rising and falling of ocean levels. So right now you can kind of see on the beach, the tide is not super high and it is not super low. And how high and low it is can vary between high tides and low tides, or the two parts of the day on the ocean, on the coast, where the tide is either the highest or the lowest. Sometimes it's high tide is higher than other times, sometimes low tide is lower than other times. And it all has to do with where the moon and the sun are in relation to the Earth and to each other. And because these are things that we can predict, because the gravitational forces are consistent and happen the same way day after watershed is essentially a region or an area of land where gravity and the topography of that land, or the relative elevation and shape of it, like where our mountains are, where canyons are, that kind of thing, determine where water falls and flows. So behind me is the Soquel Creek. It is the main tributary or branch of the Soquel watershed. So there's other creeks and other parts of the Soquel watershed that all flow into Soquel Creek, and because they flow into Soquel Creek, they're part of the Soquel watershed. And Soquel Creek is flowing into the ocean that direction where we just came from. So that makes it part of the Soquel watershed. Now, topography is the study of the terrain's elevation, relative elevation. So elevation has to do with how high above sea level a place is. So right now we're next to a river that flows right into the ocean. So we're not that far above sea level, probably only a few feet. But over there in Manteca, you guys are about 36 feet above sea level. So that means if you stacked 6 of me's on top of each other, straight on top, plus a little bit extra, then you would have about the elevation of Manteca in comparison to that of the ocean. So almost everywhere in the whole world is above sea level or at sea level, with the exception of some places like Death Valley National Monument, which is actually below sea level. So if Death Valley was right next to the ocean, then it would actually be part of the ocean. It would be under the sea. But since it's inland, it is just a desert inland in California. So this is the Soquel watershed. Let's go check out a different one. If you've ever been to the boardwalk, you might have seen this river before. This is the San Lorenzo River, and it runs out of the San Lorenzo Valley watershed and is its main tributary. This is where it meets the ocean. Over there in Manteca, you guys are in the San Joaquin watershed, which is one that's even larger than the San Lorenzo Valley watershed. It includes about half the delta as well. Thank you guys so much for joining me on this ocean exploration, and I hope the rest of your digital science camp is super awesome. Bye.